Hey, what's up everyone? Good afternoon. This is Neil. I'll be showing you how I fix the audio issues inside Steam, specifically running inside a Docker container. In my last episode that I uploaded in YouTube, the title Hacking Steam to Play FPV Logic Inside a Docker Container, I mentioned that I was having an issue with the audio. And the only thing I was able to show there, the stuff that I fixed was related to the Radio Master Zorro controller. Okay? This time, I'm going to show you what I did to fix the audio issue inside the Docker container, specifically running the Docker headless Steam. Okay? Again, I mentioned last time that I installed an NVIDIA driver around December 2024, and that actually messed up some of the applications running natively, like for example Steam, as well as DaVinci Resolve. And I've been trying to figure out how to fix Steam locally on the host machine, and even trying to reinstall Steam and its drivers. I was not able to fix it until like few days ago. Although I still did have to debug the issues because I was unable to use my Radio Master controller, and that's about the Docker headless Steam that I saw on via my search in Google. So, anyways, I mentioned it that in that same video that I was having some issues with the audio. So it doesn't mean that when audio is running fine in the host machine, it means that the audio will be fine running inside the Docker container. No, it's not like that. Container is like a virtual machine. Specifically, it's virtual machine on Mac and Windows, but in Linux, I'm on Linux right now. I'm on Linux right now, and I'm on Debian Linux 12 Bookworm. Okay, so it doesn't mean that everything will be right away, like the devices working inside the container. No, it doesn't work that way. In Linux, container is a process, and you have to map the stuff that you want to be seen inside the container. Okay, like when I say map, you have to volume map. So again, we are using Steam Headless, and I'm gonna show you what I did to fix the controller, the Radio Master controller, as well as the sound device, like the sound cards. Specifically running a sound driver like ALSA, Pulse Audio, and Pipewire. Okay, and I'll show you how I was able to figure out what sound management tool that I was using on my machine. Okay, so this is how I got the Radio Master controller working. It's not that one. It's the one where the device is named JS0, which is joystick. So I'm in VI, / is meant for searching a string. Okay, there you go. So this device becomes available when you hook up your joystick. Specifically for me, I connected the Radio Master Zorro, and I pick joystick HID on the display of my radio, and then this file became available. So you have to make the device first available in your host machine before you can make it available to the container by mapping it. Okay, so right now I don't have that device input, and there's no JS0 here, and we will only see JS0 once we connect the controller via USB port. But anyways, that's not the point of my video today. I'm going to show you how I got the device, the audio working inside the container. So there were 3 things that I've added here in the Docker YAML file. So the way to start the headless Steam Docker base tool is by creating the Docker YAML file, which is this one, and it's available on their website. And I believe I mentioned it in my previous video. So let's go to the environment, which is actually an environment that you pass down to the container to make it available. Okay, so this is the one that actually makes the audio work. This is a socket file generated by Pipewire. So how did I know Pipewire? You know, because you've been Googling for stuff. We've heard about Pulse Audio, we've heard about ALSA for so many years, and Pipewire we've also heard, like, for me, just a few years ago, and that's why I'm a little familiar with what to debug. Okay, so now what I was trying to find is, what is my Debian machine using for the audio? So I ran PSAX grep Pulse Audio. There's none. It's not running. So this one is just a grep. Okay, that's why it's displaying it. But if I do grep -v, which is exclude grep string, there's nothing, right? And then I grep ALSA. There's nothing. So the last thing I did was Pipewire. There you go. There's 2 devices there. Okay. So my machine is running Pipewire. And then to confirm more, I had to run systemctl --user Pipewire. Unknown command. Oh, I forgot the word status. Status. There you go. So it's running. You can see here. And then the other one, which I believe is kind of like a pipe to Pulse Audio, because the system is still using Pulse. So it's also kind of like a wrapper to pass traffic to the Pulse Audio server. And then there are audio tools that you can install in Linux. Let's see if I'll be able to display it. So dpkg is a tool used for showing the packages that are installed on a Debian. On Red Hat base, the command is rpm. Okay, I think you can also use yum to list all the packages that are installed. So let us see, what am I gonna do here? Maybe pactl command. Is it installed? No, it's not installed. ALSA, no, not ALSA. I believe pactl is installed. Let's see. Yeah, there you go. So I can see here, if I didn't have any Pipewire, I will only see server name Pulse Audio. And here this tells me that Pipewire is managing the audio, so it's using this. So every time an application interacts with audio, it is done via Pipewire. Okay. And then what else? This one is the socket. This is the one that we will have to expose to the Docker container, specifically to the Docker, which is called Steam Headless Docker. Yeah. So now what I'll have to do is to show you the error. We will prevent the audio from running properly. Let me let me comment this out, because this is the one which will tell the operating system to use this, okay? Use this to be able to talk to Pipewire, talk to Pulse Audio via Pipewire. And also, this won't be available inside a container until you put it in volume. So let's search for volumes. This is how you mount directories. The other one that I was showing you earlier, yeah, this one is making an environment variable. So I'll show it to you later. So let's see. This one, okay? That's the one. I can actually remove the number 2 line. Yeah, this line. I don't need this. This is what's needed. So you have to map it. This is outside, which is host. Anything that's before the colon is from your host machine, your actual desktop machine or server machine. And this one, you're making it available inside the container. That's why this one is an environment variable that points to the container file, which is this one, all right? And then you'll wonder what's 1000? So that's my user ID, and you can display that using UID, okay? 1000. And where is that found? It's gonna be in etc password pipe grep 1000. There you go. I'm running out of breath. What else? So right now we don't have the container running. It's not running yet, so we will have to launch it. But I would like to make this, I'd like to make the audio fail by commenting out these values, and we will create a Docker image and Docker container. All right, so we don't need this, okay? And then the volume, this one, okay? And then we will echo Pulse server inside the container later. So now let's start the Docker Compose, which will launch the Docker image or Docker container. So right now, see this, it's 8 seconds, we started it. And then we will terminal in to this container, connect or attach to that container by running docker exec -it and then the container name, and then we will exec bash, okay? So bash is the one that you want to run inside a container, so that way we'll get a shell. We can also use sh, but I like bash better. And then you can do ls commands or anything like this. It should work. Okay, there you go. But since we want to be inside the container, so I can show you the Pulse server. Pulse server, where is that? Oh, it's not shown. So let us cat docker pipe grep Pulse server. Okay, we would like to display this environment variable to make sure it is pointing to here. But remember, we commented it out, right? So now let's go inside, oh, not Docker Compose, Docker exec minus interactive. That one is actually running. Yeah, this one here is running the Steam. Yeah, it's running in the background. Again, remember we were using the headless Docker Steam image. So once the wallpaper changes, that's the time it will say that it's now running inside the Steam environment. Okay, there you go. Although that's not needed for our debugging of the audio. And I forgot that I should zoom in. Sorry about that. There you go. I think this is better. What if I put plus sign? There you go. That's better, I guess. So docker exec it, and then we will copy this value. I was already highlighted. And then I'm going, and then bash. Okay. We're inside. And then I said earlier, pulse audio server. Okay. Look at that. That value is wrong. That value is wrong. We won't be able to execute a play. A play is just an audio testing tool for playing a sound. So let's zoom out. I want to copy some command in here. Hopefully it's in the history. Oh, there you go. We can play this. This should play because I'm running inside my host machine.
Front, center.
Okay, but if we execute this command inside a container, remember pulse server is pointing to the wrong one. So let's play. Nothing happens, right? That's why. See, there's no audio. We didn't hear it. That's why when I was using Steam the other day, there was no sound. Okay? Now we gotta head out again to back to the host machine. Again, we are inside Steam container. See this one? Steam. We are inside the container, Steam headless. I'm gonna exit out, so we're back to my host machine. Okay? I think you'll get used to it. Host machine is your normal operating system. Container is like your virtual, and we did that by going inside the container by running docker exec. It is interactive. Okay, enter. Now we're inside the container. Look at the prompt. It's quite different. My prompt on my host machine is using oh my god ZSH. All right. Okay, let's exit out, because we are going to kill the docker compose down. We're going to kill the container. Before I do that, let me show you the docker ps. So we're going to kill this container. Yeah, this one that's been running for 4 minutes. And then after we kill it, we're going to update the docker YAML file. Okay. So now we will know when it's killed when the wallpaper changes. Okay, the wallpaper changed, right? So it's stopping now. Okay. And then if we run docker ps again, you'll see that there's only one container that's running. Okay, we're now ready to update the YAML file. So let me zoom out. And then we're going to enable back the pulse server and also the volume that we modified. This one. Oh, by the way, there's 3 that I said earlier, right? This one is very important. Dev sound. You also have to add it under devices. Okay? All right. So we've uncommented the 2 lines that we disabled earlier. So now we're going to docker compose up. Okay, and then we are going to run the same command, which is a play later. So it's up and running. Docker ps. It's running in like 9 seconds, and then the wallpaper changes again. So we'll wait. Okay, and then earlier I told you that a play did not run properly inside the Docker container. All right, we're gonna wait. Let's wait for the wallpaper until it changes from from my default wallpaper to Steam's wallpaper. That tells us that Steam is really ready. And then also sometimes it would pop up on the left part of my screen. It's an Xterm trying to install something, some library, or maybe it's enabling something. So we'll wait for that as well. Let's see. There you go. It's running now. Looking for matches. There you go. It's done. And then hopefully the wallpaper changes soon. Okay, let's run Docker PS. About a minute ago. Okay, it's been running for a minute. So the wallpaper should eventually change soon. And yeah, like what I said earlier, the command I ran earlier to check pipewire pulse, and we can actually also edit add pipewire here, and it should show the two processes running properly. Okay, and then we saw the wallpaper change like 15 seconds ago, and then we're ready to Docker exec here. So let me zoom in again. So Docker exec should be in the memory. There you go. Okay, we're gonna run bash, and then earlier when we executed pulse server, it was pointing to TMP something, right? Now let's check pulse server. Now this looks good. All right, so we should be able to hear the audio. So let us head back and zoom out. We need to copy the aplay command. I believe I place it here. Yeah, this one. Let's copy this command. Oh, not Control Z. And then we will paste it here. Okay, let me zoom in. There you go.
Front, center.
Yeah, see, it's working now inside the container.
Front, center.
So now, let me zoom out. We will hook up we will execute FPV. All right, this should be able to play audio now. Although my joystick is not connected, that's fine. Our point here is to make sure audio is now working in Steam. Okay. So yeah, let's wait. So again, like what happened yesterday, my machine was so slow, right? Still running. This is from a 2009 machine that I built, and I'm gonna make it beefier once I get my bonus. I heard we're going to get the bonus in end of March. There you go, guys. It's working. Yeah. Alrighty. My mouse is not working though. It's so below. I don't know how to quit. There you go. I have to use keyboard. Alt spacebar. There you go, guys. It's working. Finally, it's working. Okay. This
Front, center.
Nice. There you go. So to recap, guys, let's open up the Docker YAML file again. So the changes I made are under environment, specifically the pulse server line. This one. Under devices, I also added dev SND to make that device available for use by the Docker container, not just Steam. You can do this kind of code. You can add this code for any containers that you would like sound to be available. And this one was from yesterday. This is the device that popped up or got created automatically when I connected my Radio Master Zorro. And the last is the volumes, the directory or the file that you want your container to see. And that happens when you when you mount or map a file or directory from a host machine, yeah, this one, to an internal file like, yeah, this one. Okay, so like here, dev sound to make that available inside a container. That's how you do it. And then this one, native, make it available like this, and then have the environment variable pointing to that. You can actually change the value here to some weird string, but make sure that you actually point it correctly here as well. Okay, so now those are the only things that I modified to get audio working. So now both the radio controller and sound is now working on my system. And yeah, I don't have to install libraries anymore or clients. If you look here, dpkg, if I type here Steam, nothing. It doesn't show any icon to click. Okay. Previously, I have a native installed Steam. Yeah, it's working well. All right. Hopefully, guys, this helps a lot for people who are trying to debug audio and trying to get audio working inside a Docker container. So those are the things that you have to modify. And if you're not using Docker Compose, you can just use a regular Docker container, and you can do it like docker run and then -v and then dev snd, dev snd, and then -v, like run what was it again, run user 1000 pulse native, and then repeat that command again. And then what else? I think those are the two things that I did. And then environment variable is -e. Pulse server. Oh, sorry. Let me zoom it in. So that's what I typed, docker run. And I was saying, you don't have to use Docker Compose. You can do it this way. Okay, and I was typing this, pulse server equals, and then that value. And then you specify container name. Container image. Colon latest. Something like that. And then yeah, that's how you do it, guys. All right. So I just control C it. I don't need to make it work. But that's how it's really done. I forgot the Docker container's name here. Yeah, somewhere there. Yeah, somewhere here. And then let's look at some of my historical Docker run in the future. In previously, Docker run. Okay, I'm looking for some tiny proxy. There's no. Oh, there you go. That's how you specify the name of the container. Okay, dash or hyphen name, and this is the image name. All right, and this is a port mapping. So meaning port 11,101.1 is mapped inside the container as 8888, and then run it in background, which is daemon or demonize. Alrighty, guys. Hopefully you enjoyed this episode. This is a little tough in debugging, okay? And I know because I've been using Linux since 1995, and audio and Xorg are most of the stuff that's always been annoying me for years, even today. And that's why sometimes, or maybe most of the time, there are people who don't like to use Linux as their desktop machine. And yeah, and I agree, because it's tough to configure, and really tough, because most of the things will be done in the command line. Yeah, so I know. and I was a user of Microsoft Windows for so many years. I started Windows in Windows 3.1, which I guess was 1992. And then I started Linux in 1995. So it's been a lot. I've been using it a lot of times, and I stopped using Windows in 2000, 2009, I guess. I switched to Mac OS X, and that's my daily driver now. When I'm at work, I am using Mac, and our servers are all Linux, and I just terminal into them. Okay, we're using Amazon, and I manage a lot of EC2 instances, so all of them are running Linux, specifically Amazon Linux 2. But for my development on my laptop, I'm using Mac OS X, and I've been using Mac for 16 years now. Yeah, and I love it. I've never seen any virus. That's true. I've never seen any virus, even if I'm going to so many malware websites. It's really nice. It's really nice. Um, yeah. So, alrighty, guys. Hopefully you enjoyed this episode, and if you want some other tutorials that I want to talk about, please let me know. All right. All right, you guys, have a great day, and I'm gonna fly my 7-inch drone soon. All right, later.